Hello everyone, and thank you for joining us here today for our introduction to the new SuperNova PID process and temperature controllers from Precision Digital. My name is Joe Ryan, and I'll give you more of an introduction in a moment. But before we get started, I'd like to just touch on a few logistical points. First, many of you will have noticed that you are in listen-only mode. That is because there is simply too many people on the call for me to have this many open phone lines. It would be deafening. However, if you have questions or comments as we go throughout today's presentation, you'll notice that if you're on a PC, there's a chat box in the lower left-hand corner of your screen. If you are on the app, I believe you can pull up the chat box with a button there, depending on what operating system you have in your app. But I would encourage you to text in questions and comments. We may not have time for all of them today. Those we don't, I will be sure that we get back to you with answers, though, next week. Speaking of questions and comments, the number one question I receive is, can I get a copy of the slides, or is there a recording of this? I want to share it. And the answer to those questions is absolutely. You will receive an email next week that will contain both the PDF of the slides from today's presentation, as well as a link to a YouTube video where you can watch the recording. Then, of course, we would love it if you would share that with other people who you think could find this information valuable. Lastly, a personal request as a person who has to do these webinars, there is a chance you will see a survey at the end of today's presentation. If you do, it's only 3 questions. I would love it if you would take a minute to fill it out just to let us know how this is going, or if you have any other thoughts on presentations you'd like to see from us in the future, or how we might improve ones you've already seen. With that, I'm going to go ahead and get started by introducing myself. My name is Joe Ryan. I'm the VP of Sales and Marketing at Precision Digital, and I've been in the process industry now for about 18 years, where I've done everything from product design to marketing and selling of these sorts of displays and controls. I worked extensively with our old PD500 series of Nova controllers, if any of you are familiar with that. I think some of you here from the names I see are. And of course now we have the new PD500 SuperNova Series, which I'm also similarly familiar with. So I look forward to talking to you about them here today. What we're going to do here today is take a look at that PD500 series of PID process and temperature controllers and really learn about the features and the options that are available. Then we're going to briefly discuss the software and what you can do with that. And at the end, we'll likely take a look at the comparison of the SuperNova to the old Nova series line. So any of you who may have experience with the PD540, PD550, PD560, PD570, we'll take a look at how these cross over to those. Now, before we get started, I do have a question for you. Have you sold, bought, or used the original Nova series of controllers, those 540s through 570s? Is that a line you're familiar with? This will help me shape the presentation here today and make sure I get as in-depth as needed to talk about what you may be looking for. And it looks like the vast majority of you are saying that no, you have not really engaged with the old Nova line. And that's great. We'll spend very little time then talking about that. There are certainly a few of you who have clicked that you have. And for those folks, we will briefly touch on it, but we won't spend too much time on that here today. One thing I would love to point out about the SuperNova is that it is in stock now. We've got over 800 SuperNova units on the shelf. We have more on their way to the shelf shortly, and more to come after that. So if you are having problems getting a unit that some other manufacturer provides, give the SuperNova a shot. We have them here ready to ship out. Let's talk about the features of these units. Well, obviously, we call them PID controllers, so this is an auto-tuning PID process and temperature controller. Beyond that, the first thing that jumps out at you has got to be the reverse polarity 3-color LCD. So I say 3-color because there's this white, green, and amber display that's on there. The individual displays don't change color, but you've got 3 displays on there. They're reverse polarity LCD, so they really do pop out at you. This is a slick, modern-looking unit. In fact, we'll see a picture later of it installed in a panel with other controllers, and it really does pop. It'll take thermocouple and RTD inputs as well as voltage and current inputs. You do need to use an external resistor for that 4 to 20 input, which of course we do provide. For primary control options, you've got 4 to 20 milliamp output, your SCR. You've got your voltage pulse, or what they call SSR for solid-state relay drivers, and you've got just tri-contact relay outputs. So whether you're looking to do basic on-off control with a relay, or you want to do some kind of a valve position, or you want to drive a power controller with a voltage pulse output, all of those are doable. You just get the SuperNova that has the primary control drive that you need. Every SuperNova comes with a secondary control output relay. That just comes, if you need it or not, it comes on all models. And what that's used for is if you need to do bidirectional control. So if, for example, I'm using a 4 to 20 milliamp output to control a valve that brings in hot water, but then I just have a relay that's going to open up a valve that's going to bring in cold water to chill my system, great. I have that secondary relay for heating and cooling control. Maybe I'm using a solid-state relay driver voltage pulse output to drive a power controller for my heater, but again, my cooling is just done by a relay that opens a valve. Great, I've got that relay on there. So if you need to do bidirectional control, you absolutely can. You don't have to, but you've got a relay in there to let you do it. Based on feedback from the old Nova line, we made it very easy to switch between auto and manual control modes. You can see this A/M at the bottom. That tells you what to do. I guarantee you folks could look at that and figure out what to do if you were standing in front of this unit at the panel. It has up to 2 alarm relays and 4 to 20 milliamp retransmit output options. A new feature for the line is you can have a remote set value input. So you can have a 1 to 5 volt signal coming into the SuperNova, or a 4 to 20 milliamp if you use an external resistor, which again we'll provide. You can bring that signal into the SuperNova to change your set point from another device, whether that's another controller of some kind, a PLC, even if you just want to put a PD500 our 4 to 20 milliamp panel mount signal generator with a little dial knob on the front of it on your panel. Easy to do that, bring the signals in, and control them with that 4 to 20. And of course, we mentioned our software earlier. That is free programming and monitoring software. We'll take a look at that in a bit. The DIN sizes available for the SuperNova controllers are all the most popular sizes that we saw in our old Nova series. So you've got your 16th DIN, that's your small rectangular version, your vertical 1/8 DIN, that's opposed to a Trident or a ProView, some of you may know, which is a horizontal 1/8 DIN. This is a vertical 1/8 DIN controller. And your 1/4 DIN, which is your large rectangle controller. These are the most popular sizes, the PID controllers. They're a standard DIN size that's out there. Chances are, if you know PID controllers, you know these sizes, as do anyone, if you're a distributor or whatnot, that maybe you are selling these to. The front panel has a variety of push buttons and status indicators that really try to share as much information as possible about what's going on in your process. So for status indicators, you've got these small amber-colored indicators that really pop because of that reverse polarity LCD. And because it's an LCD, I can read what's on those indicators. It's not like a tiny little dot is flashing and I can't figure out what it is. It will spell out for you, run, to let you know you're in run mode, out 1, out 2, letting you know that those are the outputs that are active. Your sub 1 and your sub 2 alarm outputs, again, indicators will tell you exactly what is going on there because it's going to tell you sub 1 or sub 2 is going. Same thing with communication, or if you're using a remote input for set points, manual mode has its own indicator, as does lock. And if you're auto-tuning, there's a T that blinks to let you know, hey, something's going on, because I'm in that auto-tuning process. We took the most common unit indicators and put them in the upper left, so you can show those if you want to, but you do not have to. And then, of course, you've got your 3 displays, your process variable, your set value, and your manipulated value, or your output percentage. It's great to see all 3. The 16th DIN is small, so you'll notice that you've only got the 2 displays on there. That's just due to size limitations. But on the larger units, you've got all 3 displayed, so you can have a good idea of what's going on with this process. Finally, we've got our USB port on the front, located behind a rubber seal, so that you can get at the unit to do programming or change your setups from the front without having to open the panel. There is a USB driver on the 16th DIN, but it's on the top of the back of the unit, so it's behind the panel. And then we've got our 5 hard plastic push buttons. These are not a plastic overlay. These are not membrane switches. These are solid plastic buttons that come through a solid plastic front of this controller. You are not going to break these. They're not going to wear down over time. They're not going to break down because of UV. These are going to hold up to the kind of punishment you see in the field. Looking at the connections might help you understand all the features that these are available with. So let's take a look at, in this case, our PD530A or S, so that's the 4 to 20 milliamp output or the voltage pulse output. And the 530 lets you know that this is our quarter DIN unit. I've got output 1. Output 1 is my SCR, SSR, so that's my analog outputs that are either voltage pulse or 4 to 20. I've got my output 2. Output 2 is always a relay. That's my secondary control output if I want to do heating and cooling control. Sub 1, 2, and the shared common are the relays for alarms. Then I've got my digital inputs, which are what allow me to change between some pre-programmed set points or run and stop the unit based on a contact closure. My RET, that is my 4 to 20 milliamp retransmitting output. Lets me send the 4 to 20 representing my process variable or my set point back to the control room, or a PLC or a piece of telemetry equipment, whatever I have a need for. These can be RS-485 Modbus slave devices. If you want to have a PLC or a SCADA system pull that data out via Modbus, you can get the RS-485 option to do so. There's my remote 4 to 20 milliamp or 1 to 5 volt input to control my set point remotely. And then at the bottom, I've got my universal inputs for thermocouples, RTDs, millivolts, or voltage, milliamps, etc. And of course, down the lower left here, I've got my input power. These are 120 to 240 powered. There's only high voltage powered versions of these. Now you look at a slightly different model, like the PD530R, same quarter DIN unit. The R just means that it has a primary relay control element. So you'll notice out 1 over here is a relay versus the analog outputs I had over here. That is the only difference there. Otherwise, the pinouts are exactly the same. It's the same sort of thing on the PD520s, the 1/8 DIN vertical. Just the numbers of the pins change, that's all. But the same layout, same all options available. And it gets a little different when you get down to the PD510s. That's the 16th DIN unit. Here's where you have to make a few choices simply because of the space available in the meter. So for example, you can see in this block here that my remote input for the set point and my retransmit share the same pinouts as my digital inputs. So you can't quite get every possible option on the 16th DINs, but you can get pretty close. Other than those ones that do share space on the boards and on the pinouts, everything else is available together. These are very easy to read and operate. I've used a variety of different PID controllers, and I like the way these ones function. I think one of the reasons they function so well, as we'll mention in a moment, is the 14-segment displays. But anyone who's familiar with PID controllers is going to really be able to pick one of these up and work with it fairly quickly. You've got the information pack display that makes it very easy for operators, with your process variable, your set value, and your manipulated value, all being able to display on the 16th DIN unit. In this case, I'm doing both heating and cooling, so I've got this H, and then sometimes it would be a C for cooling to let me know if I'm in that heating and cooling mode. Otherwise, this would just be an O, letting me know that it's my output levels. And then you've got your function keys, which have some obvious functions. You've got your MD key or your mode key in order to enter your programming, set value key or set key for changing your set values or entering in a parameter, your up and down arrows, and your shift key, which could serve as your left arrow for programming digits, or you can use it to as sort of a pause and run key for the run modes. But then you've got the ability to change between your auto and manual modes. If you want to just transfer into manual mode and control this with the up and down arrows for your output, you can do that, and we tell you how to do it right on the faceplate. So you just hold that set and down arrow for 3 seconds, and it switches back and forth between your modes. Other features so that you can press the up and down arrows individually, either or, in order to acknowledge latching alarms. Any of the alarms on this unit can be set to be latching, meaning they need some manual feedback in order to reset, and either of those keys will do it for you. And you can lock the unit by holding the Set and the Shift key, which is going to enable the parameter lockout so that somebody cannot just start pushing buttons and moving around in the thing unless they know how to unlock the controller. If you're going to do setup and programming in these units, you're going to find it very similar to what you've seen on other PID controllers, meaning that all of the parameters are set up in parameter groups. You find the group that corresponds to what you're trying to do. You go and you search for the parameter, and it makes it very easy to go find a parameter that you suspect exists, but you may not be sure what it does. Makes the documentation very easy to follow. In order to go through the programming, you hit your, oh, I lost my drawing tool there. You hit your mode key, and then you're going to, or you hold your mode key, and then you're going to use your set key to enter menus or confirm settings, and you're going to use your up and down arrows to navigate around. Fairly intuitive way to program these. In the documentation, we try to lay things out in a way that's going to make it very easy to find what you're looking for. So for example, we have these parameter maps. Here's my set value group, SV group, in which I can press the set arrow to move, in which I can press the set arrow to move down through these parameters, or into the parameter programming. And we have the actual display here, so you can look up what you're seeing to know what it is, or vice versa. You can be in the menu and or manual and look to make sure you're in the right place based on what your menu's saying. And then right here, even in the parameter maps, we provide you with the parameter name, the default value, meaning that in this case, my set value number would be 1 that I am defaulting to. But I actually have 4 pre-programmable set values I could enter into this. Similarly, your set value high limit is currently set to 1370 by default. That's the high range of the input that comes defaultly programmed in. And the range that you could program is based on whatever input type you have. So just looking at the parameter maps in the manual will help you understand and navigate your menus. Of course, if you're doing Modbus work, well, we give you the Modbus addresses right here, so it's very easy to find. There's not some huge table in the back full of things you've got to try to decode. I said we'd talk about the software. Let's take a brief look at that. So the software is free, which is great, and you can use it for monitoring, data logging, and programming the units. It is PC software, so it runs on a computer. It doesn't go on your phone. And all of the data logging that it will do, just to be clear there, because it's a common question we get, and one just popped up with it actually. All of the data logging is done on the computer. It's not stored on the meter. The software is doing the data log, it's requesting the information, it's getting it back, and it's logging it onto the hard drive. So how many logs can you have in your data log? Well, it's basically infinite because these files are so small, and your hard drive is going to have so much space that you essentially have no practical limit on how much you can log. You connect up to the PC through that USB port that's on the front of the meter, which is super convenient. In fact, as you can see in this picture, there is no power cord or anything running to the SuperNova. It powers itself up enough to see what's on the display right from that USB connection. No one's going to do this, but I would not operate it like that. There's enough power to light it up and see what's happening, but don't try to run your meter via USB connection. You can connect up to 31 SuperNova controllers in one RS-485 network, bring it into your computer, and have 31 of them running in your software. And it lets you see your PV, your SV, and your MV, as well as alarm statuses, all simultaneously on essentially mock-up displays that show in the software for monitoring. You can control your set points. You can save your programming configurations, which is great if you're an OEM who wants to do the same thing over and over again. Well, great. Make one gold standard programming menu and or programming configuration, and then just download that into each unit you have. And when you do your data log, you can save that in spreadsheet files. You can export it as graphics. You can make it into PDFs. There's all kinds of features about how you can use that data once you get it into the log. Looking at the main menu real quick, just to reinforce what it does, you've got the ability to load or start your data monitoring, or all monitoring data if you have multiple units connected. Each one could be individual. You've got the ability to add serial communications connection, add more units, turn it on and off. You can open the monitoring screen, so that brings up the view that lets you monitor what's happening on all of these controllers. or you can just see it in a listing chart if you don't want to see the graphical representation. You've got the ability to open some trend graph monitoring screens so you can see what's been trending and what's been going on with your units. Or you can open up your parameter list for programming. To give you a sense of what this will look like, well, if I were to load monitor data, if I have a data log running and I open it up in our data monitor, well, now I can actually see some trend graphs, and I can see what's currently happening with these units. If I go into the monitoring mode, I can see what is essentially the front of the unit. So here's my process variable, my set point. I'm in run mode. My output 1 is going, and it shows me COM because I'm actively communicating with it. And I have my degrees F symbol lit up on the front of the meter, so here it is for units as well. You can actually graph multiple device, multiple signals or multiple values on one screen. So for example, here I've got a single device, labeled this as device 1, but I've got my process variable, my set value, and my manipulated value all being graphed. So I can see how those things react to each other and what's gone on in recent history. If I want to do my programming, I can bring up a large spreadsheet-like table that shows you all of the parameter names and what their values are. I can just go in there and change them as needed. It's not really a setup wizard, but if you have your manual handy or you're familiar with the units, it's very easy to look at this, get a picture of what's going on, step through the programming, and then, of course, save that and have it available for later. Talk about how versatile these units are. Again, a review of some of those features that we've been talking about. I've got 3 kinds of main control outputs, 4 to 20 voltage pulse or relay output. We include that secondary relay control output standard for 2-directional control. We've got an analog retransmit output when I want to send a 4 to 20 milliamp signal to somewhere else. And that's a powered output. You don't need to provide a 24-volt power supply for its loop. It's an auto-tuning PID controller, of course, so you don't have to be an expert in PID controls to get these to work for you. And it's got a lot of different relay possibilities as far as how your alarms are going to function for you. You want to use them for on-off control, you can do that. You want to have basic high and low alarms, that's fine too. Then you've got set point deviation alarms, which will move as your set point does. Loop break alarms to let you know if you've got an input failure. Any of these alarms can be programmed to be latching or automatic reset. If you want it to function as a normally open or normally closed, or you want to use fail-safe mode in case of power failures, you want it to fail in alarm state, great. You also have individual alarm delays and wide deadbands on those. So if you need these to have huge deadbands because you're doing some level control and you really want to drive that sump or drive that tank significantly down when the alarm goes off, you can do that. Each alarm has the ability to use these features. So you can do a lot with the 15 or so types of alarms there are, plus all these additional options that you can turn on and off individually for each alarm. It's very versatile in how you're going to use those extra relays. We talked about that easy auto manual control switching. Operators are going to love that. Well, we don't have ramp and soak profiles. You can set it up so that when you change your set point, it will ramp it up or down. A common request is that when someone changes the set point, they don't want their valve to slam open. They don't want the heater to instantly jump to 100%. They want the set point to change gradually over time, so there's not as much shock to the system from a set point change. And the ability to ramp your set points up and down can be used for exactly that. And to allow you to make changes to your PID response without having to be a PID expert, you've got the alpha parameter in your algorithm that you can change just by changing one parameter in the unit, which can be used to sort of broadly speed up or slow down your adjustments to the system from the PID algorithm. So if you find you have too much overshoot, or it's taking too long to get to your new set point because it's going too slow, well, great, you can change that alpha algorithm and you can adjust those speeds of responses, which 95% of the time is all somebody needs to do if the auto-tuning needs to be adjusted a little bit. A very handy feature. I mentioned earlier we had digital inputs. Here's a chart showing you what those digital inputs can do. So you've got digital input 1, which in this case is going to be used to change between run and stop modes. And then you have digital input 2, which can select between either set value 1 and set value 4, or set value 1 and your remote set value input if you're using that. So if you have some very basic changes to your set points you want to do, essentially toggling between two pre-programmable set points, or you want to turn your control outputs on and off so it's only operating when you need it to be, you can put switches on the panel, you can send it outputs from a PLC, just handy, easy features to use if you're in those circumstances. It has RS-485 for Modbus communications, where it can be a Modbus server or a Modbus slave device, so that a master can pull information out of it. And if you need serial adapters, you need this RS-485 to become a RS-232, or you want to bring it into a computer via USB. Maybe you have up to 31 units connected up in your RS-485 bus, but you really want to use the software, which is only on your computer, which lacks a 485 connection. Great. You could use RS-485 to connect and then just use an RS-485 to a USB converter and bring it right into your laptop, your computer, or whatnot. So if you need any of those adapters, we certainly have those available for you. And I wanted to talk a little bit about that mini USB port, which is really convenient for hooking up the software to a controller for programming. It is located on the front of the two larger models, the 1/8 DIN vertical and the 1/4 DIN. But here's a picture of where you'll see it on the back of the 1/16 DIN. So here's the front of the unit in front of the panel. Well, behind the panel on the top of the unit, you're going to find that USB port. So just know that there is a difference in its location based on which unit you get. We do have a variety of rugged enclosures available for the SuperNova, like we do our panel meters. These are NEMA 4X, NEMA 4 field enclosures that give you a lot of rugged protection in an industrial environment where they're needed. They're available in plastic, stainless steel, or painted steel. You can put 1 to 6 SuperNovas in them. And in addition to the enclosures themselves, we offer a variety of accessories that go with them, such as lights and horns you can easily put on top just by drilling a hole, 24-volt power supplies if you need to power transmitters, and we've got a range of signal splitters, isolators, and conditioners. So if you need that 4 to 20 out to actually be a 0 to 10, hey, great, we can put one of these in this enclosure for you, and you can get a 0 to 10 volt out of it. Taking a look at the different series of enclosures we have, we've got my personal favorite, the PDA-2300 series. It's economically priced. It's rugged plastic. It's a NEMA 4X box with stainless steel hardware in the terms of hasps and hinges. And I just find it a nice, rugged, cost-effective box, easy to work with. And it's deep, and the SuperNova is pretty shallow. So at 2.5 inches, it is not going to go far behind the panel, which means, as we've done in this picture on the right, you could put a power supply right behind the SuperNova and it would still have room for wiring. So if you've ever worked inside these panels and you're working with some 5/6 inch long panel meter or controller and it just gets in the way of everything, well, the SuperNova is very shallow depth in its case when you put it through the front of the panel. So I think you will really appreciate that. 2800 series is the version for someone who knows they're never going to open this. It's got screws that secure the top of the box on, as opposed to having it hinged. The 3400 series is another line of plastic enclosures, but this time, this clear plastic cover that gets screwed on goes over the entire unit. So there is no hole cut out of that cover. It's just a clear plastic cover, so you can't even access the buttons or the USB port. It seals it all behind the plastic. For those of you who want something a little more rugged, we've got our 2600 series of stainless steel NEMA 4X boxes and our 2700 series of painted steel NEMA 4 boxes. They're pretty rust resistant because they are painted, but after all, it's just a powder coat paint finish, and so potentially there's the opportunity for rust, which is why it's just NEMA 4. But they are rugged, and it's lower cost than the stainless. So before I get into a comparison to the old Novas, which will only take me a minute, I was wondering what is your favorite SuperNova new feature, something that we've added from our older lines that we think is, obviously all of these are going to be popular, but I'm curious which one strikes your interest the most, so give you all a second to get some feedback there. Also, it is 11:30. I do have a few more slides to finish up, so I appreciate you all sticking with me, and then we'll have a couple of questions at the end for those of you who want to stick around for it. And it's looking like the the improved display and the USB for programming are winning the day today, which is interesting. I'm surprised to see that remote endpoint percent value changes and not higher. In the past, I have had that be up there. Wow, all right, 25% three-way split now. Interesting. So let's briefly look at the SuperNova versus the old Nova series. I won't go through every one of these lines based on the feedback from earlier in the presentation. But as you can see, it is just a vastly superior unit. It's shallower depth, it has a better display, it's got more features. I mean, that sums it up. If you're looking at the two units, you can just tell from the pictures here that one is more advanced and more modern than the other, which of course it is. Some of the more advanced features on the SuperNova, like the remote set value input, the convenient features like the auto manual control change, or even being more rugged, are things that are great, and we like them because of the feedback we got on the old Nova series. So if you have some feedback on the old Nova, know that we likely address those concerns with the new SuperNova series. And of course, not only do we do all of it in a smaller package, but its starting price is lower, which is always nice to see these days. So we got a starting price of $199 versus $251. Taking a look at the new SuperNovas versus some other older PID controllers, the difference is striking. Obviously, this is the SuperNova. That's our 1/4 DIN unit installed there. And you can see that the display does just look better. It looks like a brighter, clearer, more modern unit when compared with some of these older controller types. We even got one of our old first-generation Trident series meters in there, which obviously it compares very favorably to. And interestingly, you look at these paperless chart recorders, which sound great because they've got that full-color display and such, but you really can't read those all that well. Especially older ones had contrast issues, where the display on that SuperNova is just going to pop out. It's going to be easy to read, and people are going to like it. They're going to feel like they got a nice modern piece of equipment there. Before I wrap up, I'd like to mention our PD500 multifunction calibrator. Whenever you're working with or talking to folks who deal with PID controllers, I've found that many of you are going to deal with thermocouples and voltages and 4 to 20 milliamp inputs as a sort of a service tech at times. And so having the ability to measure those signals and source those signals comes in handy, especially when it's a small, economically costed calibrator that you can just throw in your tool bag. So any of you who need that, who don't have sources and measuring capabilities just at your fingertips, I'd urge you to take a look at this unit. It nicely breaks out your input from your output terminals, keeps them separate so it can do both simultaneously. Get your output controls versus your measurement controls, your output terminal versus your measurement terminal. And in general, I find it pretty convenient and easy to work with. It even folds up into this carrying case which comes with it so that you can keep it protected in a small little case that you throw into your toolbox. With that, I will thank you all for attending. I will answer a couple of questions we've got here, go over time a little bit, but if you have to go, I thank you for your time. I hope you will find that these units are helpful to you in the future. If you've got any questions, don't hesitate to reach out and let me know. And please fill out that survey that you may see when you depart. Once again, that'd be greatly appreciated. So to stick around for a few Q&A, let's look at some of the questions that we had. So Daniel's asked the question, you mentioned that the 4 to 20 milliamp output is powered. Do these units have 24-volt power supplies? So both of those, so I did mention that that is a powered output. When we were back here on our slide talking about the pinouts, I mentioned that the 4 to 20 retransmission output is a powered output. And what I mean by that is on these two pins, it doesn't require another device in that loop. So if I had just a panel meter here, for example, reading that 4 to 20, all I'd need is the panel meter and my 4 to 20 out, and the voltage needed to run that loop is provided. However, the units do not have 24-volt power supplies to run transmitters. Those are common features on some of our other products like the ProViews and the Trident. That is not a present feature in the SuperNova line. If that is what you're trying to do, if you're trying to do level control and you need to power up the level transmitter or run the 2-wire level transmitter with a 24-volt loop, or if you're doing flow control and you need to power up your flow meter, something similar to that, my recommendation would be our 120 to 24-volt output power supply which can output plenty of power for anything you may have running your panel usually. I mean, it's an amp and a half of output, but it also is great for just running loops. And so if you need that kind of power supply, grab one of our dinner mount power supplies, put it in the back of your panel, and use that to run your input loops, because you do not have that transmitter power supply on these units like you may with others. Another question I have is, let me try to understand this. Okay, great. So this one is from Katie, and it is asking about the DIN sizes, and specifically they're asking about the old Nova size, which is the 1/8 DIN vertical, and how that relates to the enclosures, or the enclosures cut to allow for 1/8 DIN vertical instruments. So I think I understand what you're getting at, which is if you notice on this enclosure, we have a 1/8 DIN vertical meter installed in it, and it does indeed hinge open properly. We have versions of these enclosures that are designed for our 1/8 DIN panel meters that have vertical 1/8 DIN, I'm sorry, horizontal 1/8 DIN cutouts in them. However, the SuperNova enclosures are specifically cut to allow for the vertical 1/8 DIN. So if you get the SuperNova enclosure, it is aligned appropriately to install your SuperNova controller. It's not going to be something where you have to mount it sideways or do something weird. The enclosures are clearly labeled and specify what part numbers to get to work with SuperNovas. So I believe that's going to answer your question there. And as is 1:37, I have time for one more question. Let me find a good one. Here we go. Okay, Barry has a question that's pretty good about the RS-485. And he'd like to know how I can get multiple, if I'm reading the question properly here, let me know if I'm not, how I can get multiple SuperNova units into a computer through the one USB drive. I touched on that briefly earlier, but let me just sort of slowly touch on that one more time. So all of these units can be RS-485 slaves, and they do that through this half duplex 3-wire RS-485, which is going to be these two communication lines plus a signal wire, plus a signal ground wire. And so what you do is you bring out these communication lines and you string those up onto a bus where they're going to be connected up to other SuperNova controllers along the way. So I'd have a controller over here, a controller over here. Pardon my crude drawings here. So like in this case, I've got one unit, I've got a second unit over here, and I've got a third unit down here, and they're all on that RS-485 bus. Then what I would do is I would take that RS-485 bus, and I would use one of these serial adapters, such as the PDA-7485. And what that's going to do is it's going to take those bus wires that came from my 3 SuperNovas over here. It's going to put it into that 7485, and it's going to output one USB port that's going to go into my PC, which I'm an expert at drawing, as you can tell. And so that's how you're going to be able to communicate using a computer in the control room or the operator's tower or whatnot, and you're going to be able to connect up to however many SuperNovas you have in the field with the software, is you're going to be using that RS-485 bus going unit to unit to unit, and then at the end of that RS-485 wire, which can run thousands of feet, you're going to just convert that over into USB and plug it in your computer. So it's pretty easy to wire it up once you know what you're doing. With that, folks, I thank you for the extra time. I hope that you saw some things useful here. And as I said earlier, if you have any questions, please don't hesitate to reach out. I thank you in advance for filling out your surveys, and we'll see you at our next presentation. Thank you.